talk is advanced topics in Swift. I'm hoping, assuming that all of you at least have some familiarity with the language, basic syntax even. I'm going to go through an overview of the key features we're going to look at. So if you're not familiar with some of them or some of the more recent developments, we'll go through it. So we'll go ahead and get started with a little history, in case any of you are not familiar with how Swift came about as a language. It is Apple's modern alternative to Objective-C for Apple platforms, Mac and iOS, and now watches and TVs and everything else. It was created by Chris Latner and Apple. If you're not familiar with who Chris Latner is, he's a very smart guy worth looking into. He created LLVM as his master's thesis project, and now he's the head of developer tools and languages at Apple, and has a PhD in compilers. So smart guy. So he began work on it himself as a side project in 2010, and some other engineers saw it, liked it, they got a team, and it reached 1.0 release in summer of 2014, and Apple put their full weight behind it. So it took inspiration from a lot of different languages, stood on the shoulders of giants. Latner is quoted with this: Objective-C, Rust, Haskell, Ruby, Python, C#, CLU, which I had to look up, and a ton of others, far more. So why Swift? Why do I love Swift? Why I think other people should? It's a language that supports many paradigms. So you can go object-oriented, purely functional, procedural. You can write very low-level code. You can use higher order functions, but get C-like performance. And most importantly, it's safe, unless you explicitly ask for it not to be. Another name you may have heard of, Eric Meyer, tweeted that last year. At this point, SwiftLang is probably a better and more valuable vehicle for learning functional programming than Haskell. So that's a pretty strong statement to make. But it got me into functional programming, so I would happen to agree. So the key features that we're going to look into today are immutability, value types, and copy semantics. So those are core to the language, and they provide a lot of power with the sort of patterns we're going to look at. Generics, which I'm sure most people who have done used modern languages are familiar with generics, but it's going to look a little bit different than C# or Java, if that's what you're used to. We'll look at protocols, which is much like a Java or C# interface. Protocol extensions, and traits, which is a more academic language term for what that is. Scala uses traits, if you're familiar with that. We'll get into that more later. And a few more things. We're going to look at enumeration types, which in Swift are a fancy type of tuple. And what's cool about them is you have associated values with your types that we'll get into, and you can do pattern matching on them. Optionals, which are just a fancy type of enumeration, a fancier tuple. And we're going to look at optional chaining and safe unwrapping of optional values, and with language level support with keywords like guard and the guard let pattern. And property observers, we'll look at that. That's another language level feature. So we'll start with immutability. Look at some examples. So most of us are used to mutable code. In a lot of modern languages, you have a var keyword with type inference. So you can create a string, and then you can go modify it in the next line. And there's no problem with that. Well, you can get compiler enforced immutability with Swift. There's a let keyword. If you're familiar with F#, you've probably seen that. And modern JavaScript, you can have const variables. So in this case, you assign a value to your variable in the next line, or a few lines down. You try to modify it, and it won't compile. So that gives you a lot more predictability in your code. You won't accidentally mess things up when you forgot where you previously assigned something. What's really cool is it works for members of value types as well, so it's not single variables. So if you've done any iOS programming, you've probably seen the CG-rect. It's the basic rectangle structure in core graphics. So when you're doing layout code, you've probably worked with those, and you might be trying to modify where something is on the screen. You move its origin, the x coordinate. Well, if you want to ensure that you don't accidentally do that, make your rectangle a let value, and then you can't change its properties either. and the compiler will enforce that. So generics, in this case, looks probably pretty familiar. That's just the basic Swift generic syntax. Looks a lot like C# or Java. There's a few things that we'll look at how it works later that are interesting in Swift's generic implementation. When you look at protocols, for instance, which are coming up next, they're always implicitly generic. So there's an implicit self-generic type parameter for every protocol. So when you're doing generic constraints, you can actually constrain on the implicit self. So that's something very interesting in their type system and their implementation of generics to keep in mind. So protocols, which are going to be central to some of the things we're going to talk about today. You've probably done something like this in an iOS app or a macOS app, right? You have an IB action, a button was pressed, right? And then maybe you want to write something to the database or send something across the wire, and you don't have a network connection, right? So the operation fails. And in Cocoa fashion, you get an error that might be nil or it might not be. So if you have an error, what do? You have to tell the user, usually. Maybe you do some other stuff first. And how many times have you written that code where you instantiate a UI alert controller, give it a button or two, set a title, and then you have to present it? And that's a ton of boilerplate that you write over and over and over, right? So that's not very dry, right? So how can we avoid that? Well, we can create a protocol and use a protocol extension. So that's what this looks like, and I use this everywhere in my code. So I have a protocol called alert presentable, where I define a method, present alert. With a title and a message, you could do different overloads, do just a message, maybe even take some UI alert actions. And then what I do here is I extend alert presentable. So that's extending the protocol, not a concrete type. But that's what I mentioned about that implicit self parameter you get on every protocol. What I'm saying here in the extension is that alert presentable is only extended with that implementation where the concrete type is a subclass of UI view controller, which is a very powerful feature. So now in my view controller, all I do is say that it conforms to alert presentable, and now I have that implementation there. So it's a form, if you will, of multiple inheritance, you can think of it that way, but much safer because you don't inherit any state. It's just behavior. It's a default implementation. And those are also overridable, right? I could override that same method in my concrete type and then call super, which would call the protocol implementation. So it becomes part of the inheritance hierarchy, but there's no vtable, nastiness like in C++. You don't have the diamond problem. It is known at compile time what methods are called by who. So yeah, this keeps my code dry. I do this everywhere. I use this in all my projects. So that way, when I want to show a message, I call present alert, and that's it. So the next thing we'll talk about is enums in Swift. Just about every modern language has some sort of enum type. I'm sure you're familiar with it in your other languages of choice. And so that's probably a pretty common example you've seen, right? A shape can have many different types. In this case, we have 3. So what's cool in Swift is associated values, because enums are tuples. So you can define it that way and say that depending on my case, I have a value associated, or multiple values. And those values can only be accessed when I know what case I am in, right? So when I have a shape variable, I can only access radius when I know that that particular shape is a circle. I can only have width and height when I know I have a rectangle. So you can avoid having bad state, right? You don't want to have a rectangle and then try to access its radius property, right? And we'll see how you can, do something less contrived with that in a minute. Continuing with that, you can pattern match with enums, which, if you're familiar with any other functional languages, I'm sure you've seen pattern matching as well. It's core to most functional languages. So in this case, we have a shape constant variable, and we define it to be a circle radius 10. So switch in Swift is more powerful than your typical switch in like a C or a C#, because when I switch on my case, I can extract that associated value with it. So what I'm doing here is inside the scope of the circle case, I have access locally to radius, but I don't have access to it anywhere else. So it's safe. I'm guaranteed that it has a value. because those are not nullable floats, right? Those have to be non-null, non-nil. So that's a very powerful feature, and we'll see a more powerful example of switch and pattern matching later as well. Just one note also, in case you're not familiar with the syntax of these cases when I'm using them, I'm not saying shape.circle, shape.square, I'm just doing .circle. If you haven't seen that, that's part of type inference in Swift. It's known by the compiler because the variable myShape is a shape. You don't have to repeat the enclosing type when you actually use the cases, so it's inferred. So it's a bit of syntactic sugar, but keeps your code less verbose, non-Objective-C-like. So optionals, they are, as I mentioned, a fancier type of enum, right? And enums are a fancy tuple. So an optional is a generic enum. So we're combining several things now. And an optional has two cases, some and none. Some has an associated value with it. So this is a simplified version of how it's implemented. That's how optional is defined. And then there's a nil literal convertible protocol that's built in the Swift base class library that pretty much says I can assign nil to a variable, and that's the constructor that's called. So if I say optional foo equals nil, I'm actually calling init with a nil literal and set it to none. And then I can use let my nil string is an optional string. And then when I switch, I can actually do case sum and extract the wrapped value, which I know is non-nil now. So everything inside the sum scope is guaranteed to be non-nil, so I can safely use it. And then I can do a safe handling of the none case. So I'm explicitly having to deal with nils. I can never forget to check. Fortunately, just because it's defined this way, because it's a first-class feature of the language, there's syntactic sugar. So you don't have to use an optional of string and switch on sum and none. You get syntax string question mark, and then we'll get into the unwrapping to avoid the switch in a minute. So a string question mark is an optional of string. Something I'm not going to show really today, but it's worth noting, because generally, if you're using these too much, you'll see string exclamation mark in some places. I'm sure you've seen code with exclamations in Swift. That, if you're using it too often, is probably a sign that you're doing something wrong. You need to reevaluate it, right? So that's called a force unwrapped optional. What that means is you can use it like it's non-optional, but it's still optional. So if you try to call something on it and it happens to be nil, you get a runtime exception and a crash, most likely. So you should only be doing that. When you do that, what you're saying to the compiler is, I know what I'm doing, trust me, right? Which, how often is that a good idea? So generally try to avoid it. You better actually know what you're doing if you're going to do that. So the other syntactic sugar you get around optionals with safe unwrapping, so instead of having to do a switch and handling the sum and none cases, you get language level support for this. With, in addition to keywords you're familiar with, like if, while, and for, there's a new one called guard, which you can think of as a sort of an inverse if in its behavior. So I'll show how that looks in a minute. And along with these keywords, there's a pattern you can use where you do if let or guard let, right? All these different ones. So what you're doing is unwrapping an optional value and only continuing the if block if it unwraps. Else, the else block is handled in the nil case. So if you look on the right, we have a function requires an int that takes a non-nil int, right? And we define foo as an optional int. So we cannot call requires an int with the optional. It's a compiler error. So first we have to unwrap it. We have to explicitly deal with nil. So we can do if let value equal foo, then we can call it. And inside the scope of the if block, value is a non-nil int. We've unwrapped it. But it's only accessible inside that scope. In the else block, you don't have access to it. Outside that, it's still an optional. So the idea is that through keyword support and scoping, you're forced to explicitly deal with nils in a safe, much safer way, and you can't accidentally access nil values that you shouldn't be accessing. So the parallel to the if I mentioned, the inverse of it is guard. So we'll look at how you could invert this with a guard let. And in cases like this, I think it's usually a better way to go. It looks like that. So what this does for you is when you guard let to unwrap an optional, value is now in scope after the guard statement for the rest of the method. So guard brings the concept of early exit, right? So I enter a function, I start executing, right? And maybe I need to validate some parameters. Or if I'm inside a class, I need to validate my class is in a certain state before continuing. Otherwise, I shouldn't continue. I should exit the method early. So instead of doing a bunch of if blocks where, I may get the scope wrong, or, I might have them littered throughout the method, I don't do everything up top, right? I can actually use guards at the top of my method and check my parameter values or check my state and make sure I don't have nils and do an early exit if I need to. And it's syntactically easier to read and easier to reason about what your method's supposed to be doing. So the other key point about that is the else block in a guard statement must return. So guard forces an early exit if it fails. So anything you do inside the else has to exit early. And then you get everything else in scope afterward. So I use that all over the place to sort of check my assumptions and invariance before I execute the method. Finally, with optionals, we'll look at chaining. You've probably seen this in C#6 if you're a .NET developer. There's several other languages that have similar concepts. The idea is that I can chain I can chain optional unwraps both with variable accesses, property accesses, or even method calls. So in this case, foo is an optional, and it has a value. But when I need to return a bool, right? And I need to call this found the answer, right? As an extension method on int. So that's a joke, if the 42, if you didn't get it. But so I want to be able to call this whether or not foo has a value, right? Maybe I got foo over the wire. Maybe it's the result of a network call or database access. Maybe there's no row that I'm looking for in the database. So instead of having to do, if I found it, or if error is not equal nil, or all these other things I'm sure you've seen all throughout Cocoa, I can just call the method, but I do question dot. And what that says is that if foo is nil, then the whole method chain becomes nil. So in this case, the coalesce operator, double question, I'm saying if this whole chain ends up as nil, coalesce to false as my default value. So now I have something that conveys my intent, right? Instead of having a bunch of branching statements that's hard to follow, and just less typing, which there's benefit to that. The more you have to do nested ifs to check null and things like that, it makes your code much harder to read, much harder to follow. So this is a very a nice, elegant syntax for dealing with nils. So the final feature that we're going to do an overview of is property observers. This is a very, very awesome feature. A lot of times you want to observe changes in a property, right? Whether it's for model binding in like an MVVM style pattern, or there's plenty of use cases, right? Maybe you want to validate that something is correct, or maybe you want to write it to a log file or something. In this case, we have a property defined in our struct. It's an int, and it's an auto property. So there's a getter and a setter implicitly there. And we can now define, with language keywords, observers on changes to that property. So will set is called when the setter is called, but prior to actually changing the value. And did set is called immediately after the change. And you get some contextual variables inside the scope of these methods. So if you look inside the will set, a pretty cool property is the current value, and I have new value as an implicitly defined variable, which is the incoming about to be set value. So if I want to execute some method that looks at the old value and the new value and maybe animates a transition in state, something like that, I can trigger that there, either before or after a property is updated, to maybe run an animation or something like that. So, and we'll be using this in a demo in a little while. So it's a very cool feature. So the reason I go through all these features is this is my point in giving this talk. These features, they're not just cool in a language nerd way. They actually help you out. They make your code safer, deterministic. At compile time, you can know what code is going to execute and be confident about it. the compiler can be your friend and do a lot of checking for you. And it makes your code easier to reason about. If your code gets too complex, too verbose, too many branches, it's hard to keep it all straight in your head. We're not computers. So let the computer be a computer and do what it's good at. So next, where we're going with this is, how can we actually use this in a real application? Because a lot of these examples, whenever you see an example of a language feature, you can't, it has to be contrived, right, to put it on a slide. So how can we actually improve our real software with this? So I want to start with MVC, right? It's a pattern we all use. It's central to Cocoa. It's central to ASP.NET. It's everything that we use these days almost has some flavor of MVC in it. So let's start with our favorite, the V and the C, right? The old view controller, which if you've been doing Cocoa for any amount of time, I'm sure you've heard that that is the meaning of MVC. If not, yeah, if you haven't heard that, now you know. But how many times have you written a table view controller where, in addition to handling things like, styling of, the standard, the navigation bars and buttons, the same controller is also the data source for your table. It's the delegate for your table. It handles everything. And without thinking about it too much, your view controller can easily balloon to 500 lines, 800 lines. I've seen that happen in my own code. So aside from the good idea of splitting out your data source and delegate when you can, that's just my 2 cents, put them in separate files, separate class. Aside from that, there's other things we can do to make our view controllers a lot easier to reason about. Because modeling view state is hard. I don't know if you're familiar with that, if you've run into any of the pain of modeling view state effectively, but it's a very hard problem. It's hard to reason about. Especially in modern applications, they have a lot of features will be rendered on a view. Users have come to expect a lot. They like nice animations, It's hard to keep views simple. There's just a lot going on. So the problem is, how can we account for all possible states in a view, right? What's the happy path? What happens when an error occurs? What happens when we have to wait for a network call to return and we have to display a loading indicator? Something like that. There's a lot of possible states that can be in a view. And along that line, how can we account for all possible state transitions? Because you don't want jarring updates to your view, right? Again, users like animations. They like smooth transitions. So when your state transitions, you're going to have to animate it or something like that. So how can you account for every possible path through your view, right? And what happens if you forget one? What happens if, I don't know if you've ever run into this before, you try to insert or remove sections or rows from a table view, and then when you call the end animation transaction on it, or after you've done that, it doesn't match your data source, and you get a NS internal inconsistency exception, and your app crashes and burns. And then have fun debugging that, right? So that happened to me a lot, right? I'm sure some of you have seen that. So I have a demo to show you some typical iOS code, and then we'll refactor it using some of these ideas and show how we can make it better. So, all right. Alrighty. So we have a pretty simple app. We have our delegate that doesn't do much. And then we have we'll kick off our demo from our view controller here. So we have a typical complicated UI table view controller, right? So how many of you writing an iOS app have had to write some sort of a form, right, to collect data, or maybe a settings page? And the typical design for that on iOS is what? A table view, right? Maybe it's in the grouped style, you have some sections, and you have maybe a label in a text field or a label in a switch and something like that. That's the way Apple designs their settings UIs. It's sort of idiomatic iOS design for settings or forms. But that state gets very complicated, right? Because you have to handle things like validation. When you submit that, you have to handle probably loading. Maybe there's sections that appear and disappear depending on the data entry from previously up on the form, right? So it gets very complicated. So that's what we've modeled here today. So I will go ahead and run it, show you, and then we'll look through the code. No, good coat on the beach orange here. Oh, sorry. I was testing out my my refactoring view controller. There we go. Right, so here's our little form, and maybe we're going to ask the user, do they want to enable this cool feature we have available to them? If not, we have nothing more to see here, right? They can cancel. But now they do want to enable it, so we need to prompt them for some more information, right? So this is our hello world on steroids, right? So we're going to enter a greeting and a name. So, right, so as soon as the form becomes valid, I add a submit button, right? But I want it to not be there, right, when it's not valid. All right, so I can submit, right? Now I want to show a loading indicator while I'm submitting. And then say network call returns and I do something with it, right? So let me show you a bug I created accidentally while building this demo. So I'll show you the problem with writing code this way, right? So here we go, I'm in this state of feature is going to be enabled, letting the user enter data. It's not valid yet, so there's no submit button. User changes their mind, right? Okay, great. Well, let's start over. Let's make the form valid. Now we change our mind. I did not account for a particular transition, as I mentioned, right? I removed only one section from my table view, not two, but my data source said there should only be one afterward, right? In this internal inconsistency exception, crash and burn. And how many times have you seen that happen in a beta tester's hands or in production, right? You just didn't quite test your form through that possible flow, but your users did. And it crashes and burns, right? That crashes the app. So users don't like that. So let's look at the problem code. So this is fairly typical boilerplate, right? I load a group table view, which, in case you didn't know you could do that, there's no interface builder here. This is totally in code. There's no IB, no storyboard. So you can override load view to actually customize loading the view and do a group table view. But then, register some classes for my cells. We'll go through some of these in the second demo, the details of that. Again, no interface builder, all code. So then I have, my data source, right? And how many times have you written code like this yourself in a complicated sort of form-based table, right? Where you check some state and say, okay, in that state I only have one section, right? Otherwise, I need to say, am I valid? I have two sections, otherwise I have three, right? And then maybe when I'm determining the number of rows in my section, I switch on the section index, right? And then return how many rows should be in that section. If you're doing a table view like this and you're not doing it with static cells and interface builder, this is typically the way it's done. Apple has examples this way. I'm sure you've all, or most of you, have seen code or written code like this. And as you might guess, it's fragile. We saw it crash. It's fragile. And then here's my self-enrolled index path, which is a beast, right? More switch statements. What section am I in? What row am I in? And then configuring my cells based on state. I have some checks where I say, if it's not an index I'm expecting, I crash early, so I'll find it during the debug process. But this is still gross, I guess. It's hard to reason about, hard to follow. A lot of branching, a lot of switch statements, and just, very hard to follow. And then let me find my event handlers for the switch being toggled, the text changing, and the button pressing. So this is where the bug is, right? When the switch changes, I say if the switch is on, I insert a section, right? Otherwise I delete it. That way I can animate the transition. It's not jarring, right? Well, what I did was I forgot to check. Do I have two sections or three, right? Because I need to remove both if I have three. And I didn't, so there were three. I removed one, and then my data source said there was only one remaining, so boom, right? But if you're just skimming through your code, would you have found that? Right, I didn't either. So code written this way, dealing with these states and state transitions is just impossible to reason about, right? So we're going to look at how we can refactor this view controller to make it not complicated, to make it better, and get rid of this bug and make the code a lot easier to follow and a lot easier to avoid bugs like this. So let's go ahead and wire it up so we don't have that fun crash again. I'm going to switch to use our better view controller, which is not implemented. All right, so we have a somewhat blank slate to work with here, right? So we're going to implement the event handlers differently. We're going to implement all our data source and delegate methods differently. So where I'm going to start is with, we talked about enums, right? And their associated values. Well, we're not going to be doing circle, squares, and rectangles here. I'm going to show you a much more powerful way of using it. I have copy and paste code, so I don't have to type all of it. I can grab it. So I'm going to start by modeling the state of the view with an enum. So there will be predefined states my view can be in, and it can't be in anything else. So this is forcing me to reason about my view as a whole, right, in its state. So, this is a simple form, right? But I came up with these 4 possible states given this use case, right? The feature is disabled. The form is invalid, but it's active. The form is valid, ready to submit, or it's submitting. It's in a loading state, right? So those are the 4 we walk through, right? Either the switch is off and it's disabled, switch is on, but the form data is invalid. The user's entered their data and it's valid, or they've hit submit and we're waiting. So now I can do this. Right? Now my view controller will have a private property of the view state with a default value. And the best part is that we're now going to observe changes to that property. Right? So I talked about using this to toggle animations. Well, that's what we're going to do, right? The problem that we ran into was an animation that we didn't account for one possible path. So let me show you this function. I'm going to paste this in because it's a bear, but we're going to go through it. Put it at the bottom, it's private. So we're going to define a function that will handle all our state transitions. Given one state, our old one, going to a new state, what should we do? How do we transform the view? So here we go. So let's go through this. Everybody read it? I can blow up the font size if you need me to. Okay. So we take in our old state and our new state, and this is where the switch, the pattern matching, is really powerful. So the examples I showed you, we only had one value we switched on. In this case, we just created a tuple, and now we're switching on it. So we can actually switch on every possible case of old state and new state, every permutation, right? And we can define what's valid, what's acceptable, right? So we're going to ignore cases where, it's self, right? We're not changing state. So if we got through, we assigned, because there's associated values, right? We might assign invalid to view state, but we were coming from invalid. We just have new text that we're keeping track of. So we're going to ignore those. There's no actual transition we want to account for. But after that, it gets interesting. We can say, the only valid transition from the disabled state is to invalid, right? I shouldn't be able to toggle the switch and somehow be submitting the form, right? The only place we can go from being the feature turned off is to turn it on and be invalid, awaiting user input, right? So when that happens, we insert the second section and animate it. And we can say when we're invalid, the only places we should be able to go are either back to disabled or to a valid state, awaiting submission. And then we can handle the animations for both of those transitions explicitly. When we're valid, what are our three possible states? We can become invalid, right? Clear out of form. We can submit. Well, here's the case I forgot about in our first example. The user could toggle that switch, right? In this case, we need to delete 2 sections from the table, right? So now we've accounted explicitly for the possible transitions. When we're submitting, right, we're in a spinner, the only case we're going to go back to is valid. We're not going to suddenly become invalid, right? We submitted the result. And then what we're saying is that in any other case is invalid and will crash. And we'll do this, we'll find out early. And it's something that's testable if you wanted. You could exercise this view controller with unit tests and try transitioning through every state. This way we're explicitly defining what can happen, what can't happen. And anytime the state changes, this function's called, it will account for everything. It's, are you familiar with the idea of being idempotent? There's different pronunciations, right? The idea is that coming through here, the same thing should happen every time. Given one old state, one new state, the exact same thing will happen no matter what. And that's, it's verifiable, it's easy to reason about. So there's our state transitions. Any questions on that? Okay. So, let me go back up. So, I'm going to add a little bit to our enum just for convenience, some things we can use down below to clean up the data source code. So I don't want to spend too much time on this, but it's something, all the code will be on GitHub, you can go through it. But pretty much what this is doing is saying, I'm letting the view state itself tell me, am I in an enabled state or not? So saying if disabled, false, otherwise I'm enabled, right? And then I can keep track of, extract a sort of a safe extraction of the associated settings of the greeting and the name, right? So I can say, give me the settings. If they're nil, it means I'm disabled, right? So it's a sort of giving myself better syntax down below to interact with this view state. And then my validation logic is actually handled in this constructor. I pass in settings, which encapsulates those 2 settings, right? And then this checks. If either of them is empty, then construct an invalid state, otherwise construct a valid one. So now let's implement our data source and delegate methods and see how they look different when we're modeling the view state this way. So, actually before I do that, I have one more thing to show you. Where is it? Here we go. So I used one more enum to actually model the sections in my table view in a strongly typed way. So I have 3 sections: the switch, the text entry, and the submit button. And then I actually have another private field where I compute, given my view state, what should my sections be, and return an array. So now I can query this variable in my data source, and it will look at my current state and tell me what my proper section should be. So I'm not having any branching code inside my data source methods. It's all in one spot, right? Does that make sense? So now, when I go down to my data source and I want to see how many sections I should render, my number of sections in table view, instead of having branching code, ifs and elses and switches, oops, hold on. I will just use that. All right? I don't have any of that branching logic in here now. It's all that logic is encapsulated in this property. My number of rows in section. I don't have to try to look at my view state and determine what section I should be showing. I can look at my active sections and switch on that with strongly typed values. So that's much more much easier to reason about, right? And then we will, this is still a bit large, it could be refactored to private methods, but the self-erode index path can still be easier to reason about in a similar way with strongly typed sections. So we're not switching on a row index or a section index anymore. We're switching on a case in an enum. And we're not checking view state here. Again, that's encapsulated in that property, right? Any questions on that? And I will just real quick fill in the last few bits of boilerplate and then show you how we avoid that bug, the crash. All right, that should be it. Oh, I forgot one last thing. Our event handlers. So our event handlers become a lot simpler too. So in the case of toggling the switch, we're not dealing with animation code down here anymore, right? All we do is set what the view state should be, right? And when we set that, the property observer triggers our state transition function and the animations are handled there. Right? So that was where our bug was before. And same with our text box change event handler. It's the same idea. We just see what row we're on, modify the appropriate setting, and then set the state. Same with our button. There's our guard let, right? So I need to add my present alert there. So our viewState.settings, remember that was our safe check. It was an optional, so that returns an optional. So what we're doing is saying ensure that we have state accessible. Otherwise we should never be here, right? This should never happen. And then we call our service and present our alert. So this was, I showed you this in the slides earlier to get my, just add that, and now I have that behavior compiled. There we go. So let's run this, and there should be no more bug, no more crash. All right, so so before, if I toggled it from this state, that's when we blew up, right? So no more crash. So everything is accounted for in our state transition function. No branching all over the place, all over your file. So easier to reason about code, right? So that's it for this part of the demo. Let me go back to the slides real quick. All right. So yeah, after our refactor, we've accounted for all our states, accounted for all our transitions. Because of associated values, the data we care about, they're localized to the states, and we can't access them when they're not valid. So let's go a little further with MVC and look this time just at the views. And how many of you have written view layout code? Yeah, so without interface builder or auto layout, it can get a little hairy, right? Complicated. The math isn't usually that hard, but how readable is the code? Not very, right? It's hard to follow, and it can end up all over the place. Frequently, your views become bloated and tightly coupled to the layout logic, or worse, the controller itself. And what happens if you want to reuse that layout logic somewhere else? Is it copy-paste reuse? Probably. So how can we extract that, right? Make it reusable. I can use it somewhere else in the app. How many times have you had a layout that was maybe inside a UI table view cell, but you wanted to use that same layout somewhere else, not in a table view cell, right? maybe in a collection view, or you want to take sort of a snapshot, right? Show it somewhere else later in the app. So instead of writing that layout code twice, we can extract it out. So that is the other bit of demo code I promised. So those cells, I told you, the switch and the text entry cells, there's no interface builder at all in building those. So let's look at the switch, for instance, right? That is not a standard out-of-the-box cell you get. That's not a cell style, right, that you get for free. You have to build it. So here's how I built it. It's pretty short and sweet, right? We have our two subviews, a label and a switch. We have a delegate protocol, right, to fire back events. We add subviews to our content view, add an event handler, and then standard UI table view cell lifecycle stuff, right? Prepare for reuse and handling of the private event handler, right? So this is the method that I'm sure you're familiar with, right? That usually can become awful. Much more than 3 lines, right? Maybe 30, I don't know, something like that, and a lot of math, right? So this right here is reusable layout, right? I've extracted the layout into its own type. I could use this on a different type, maybe on a collection view cell, right? If I wanted to have a switch like this, but use a collection view, maybe so I have a more flexible arrangement of cells, right? Maybe I want to you can do some cool animations, right, with collection views. So what I can do is just tell this layout, and I'll show you the implementation here in a minute. Here's the views you care about. Lay them out inside this rectangle, right? And it goes and does it. So let's look at it. So I've done it as a struct, right? So it's nice and lightweight. You get copy semantics. It can have, you don't have to reuse it, right? You can do it anytime layout needs to be run, right? And I have this base type here, protocol. So we just define a contract that a layout type will lay itself out inside a rectangle. And there's this keyword, if you're not familiar with it. This just tells the compiler that in a struct, I'm declaring this function can mutate internal state, right? I will take my internal members and I'm going to do something to them that mutates them. In this case, I'm going to set their bounds on the screen, right? And then I've created an extension on UI view that just sets the frame, right? Now what's powerful about this is how many times have you wanted to not just animate a view or move a view around, but you want to lay out layers? Have you done any core animation layer work? Well, now you can have both of them conform to layout and set their frames. So you can have your concrete layout types be generic, not just take a UI view. They can take a generic type that might be a layer instead of a view, right? Because they both conform to that. So then once I'm inside here, when I am told to lay out my members inside a rectangle, I just do my layout code. And it's all right here. It's all encapsulated. It's reusable. Again, if I want to use this on layers instead of views. Maybe I'm writing there's a game-like aspect, right? And I want to use sprite kit views, right? They're not part of the UI view inheritance hierarchy, right? So you could extend a sprite kit view to be conformed with layout and then reuse this code with that. So the core part here is that this doesn't need to know that it's working with UI views. All it needs to know is that whatever it's working with has a rectangle on the screen and do some math with it, right? I would encourage you to look into some of this when if you want to download the code on GitHub. That is one of my favorite methods on CGRec that nobody knows about. And it's really nice to use in Swift because you can do destructuring with tuples. So what this does is it divides that rectangle at a point from an edge and gives me the two divided rectangles back. And I can assign them in one statement. So it makes for much more elegant code. So I'd look into that method. Okay. Nope, not add a slide. Yep. All right, so the last couple of things I want to mention are if you listen to Apple talk about Swift, they're going to call it a protocol-oriented language, or talk about protocol-oriented programming, which I think, with my alert presentable example, you got a taste of that. The idea is that using protocols and protocol extensions with the sort of the trait-like behavior, that's a very, very powerful language feature. C++ developers have loved multiple inheritance for years, but it's inherently unsafe in that implementation because mostly you inherit state. And whose state do you use? And also, when they're all virtual methods and they're looked up at runtime, which implementation do you use, right? In this case, there's no inherited state and it's determined at compile time. So you get all the power of that multiple inheritance, but none of the danger. So that's one of my favorite features of the language that I would encourage you to all look into more deeply. And then enums. There are even more ways you can increase your code safety with enums. So looking at that, I mentioned that. Yeah, it looks like Scala traits. I spoke without showing my slide. Yeah, so you don't have the vtable problems, the diamond problem, right, of C++ multiple inheritance with protocols. Enums, how many of you have magic strings or numbers in your code? I mean, I try to avoid them, but they happen sometimes. Well, enums are a great way to get rid of them. You might have noticed UIKit has a lot of them built in. Are you familiar with that method, prepare for segue? And what do you do in that method? You ask what the identifier is, and it's an optional string, so have fun with that. So I'll show you how I get around that real quick. I don't actually have a demo of this in action, but I encourage you to go find this on GitHub after the presentation and then copy and paste this into all your projects and use it. What we're doing here is saying that this protocol, segue handler type, doesn't have any methods. All it does is force you to define a nested enum on the implementing type. And it's generic, right? So this means that it will have a generic segue identifier type, and it has to be raw representable. What that means is it has to be an enum with a backing primitive value, like an int, or in this case, a string. So what you can do is define an enum. No caps lock. Right? That maybe you have a case called push details. Right? And that's your storyboard segue identifier, right? Maybe you have a present error modal, right? You can see where I'm going with this, right? So you can define your segues in a strongly typed way. And then, by extending segue handler type, where the implementing type is a view controller, and the raw value is a string, you can now, instead of interrogating the identifier yourself and switching on a string, you can call segue identifier for segue, get your enum value back, and switch on that. Right? So you're guaranteed, you handle all your cases, because switching on an enum requires you to handle all cases. And you don't have to worry about typos, right? You've gotten rid of your magic strings. They're all in one place. I can't take credit for this. This is from an Apple WWDC talk. But this is what they do internally, apparently, and they recommend it. So finally, I'll leave you with a few references to take a deeper dive. The first two are videos from this year's WWDC. I'd highly recommend both. They're great talks. Number 2 shows you some good refactoring techniques like we went through in the demos today. Number 1 goes way deeper with using structs for layout and extracting your layout code and modeling view state. That's where I got a lot of the inspiration for this. Advanced Swift is an awesome book. If you're familiar with Objective-C.io, the blog, it's by them. If you know them, you know they're good. It's a very, very good book and goes way deeper than this talk has time to go. And then, of course, just the language reference itself, the Swift programming language, very well written. It's updated regularly as the new features come out. As I know, I'm sure you're all familiar, Swift is rapidly evolving. So there's actually a beta version of the book out for Swift 3, which is in beta for fall release. So those are my go-to references. I'd recommend them. I will be checking in the refactored code here as soon as this talk is done, but you can go to GitHub and get the presentation slides and the code demos. And that's it. Any questions? Oh, yeah, yeah. Questions, comments, concerns? Yeah.
It was so much easier to see what you did, I guess, after the code for the refactoring.
Uh-huh.
How do you keep that in mind, like, at the beginning?
I don't wait now to refactor. I try to, when I create a new view, model it that way up front when I can.
You just add to the like
right.
expected views as you go.
Right, and so the idea is that when I need to add a feature, right, a new state to my view, so I add a case to that enum, and now my switch statements all break, right? The compiler tells me everywhere I need to go account for that new value, right? So that's makes it safe, right? I don't miss a spot, which is what happened in the first case, right? I missed an animation. So letting the compiler be your friend, it's a good thing. Anything else? No? All right. Thanks for coming. Cool.